I think we're live here. Day 3, using ChatGPT to teach me linear algebra from scratch. No human teacher, no $3,000 community college course. Just seeing if I can get through all of linear algebra, despite knowing none of it before, in 30 days. So, jumping into this, I'm going back to my initial response that I got from ChatGPT Deep Research with the lesson plan. We have lesson 3 right here. And I'm going to go ahead and quote and say, I'm ready for this lesson. Make it an hour long. Now, what I want to also do here is I'm going to try using the O1 Pro model of ChatGPT. I have right now 4.0 going, and it's been okay, but I did notice last time that it was making up some incorrect answers and having some issues. So I'm going to copy this here. I'm going to say, I'm learning linear algebra from scratch. This is the lesson plan for today. Give me an hour's worth of work on these concepts. Let's see if it gets that. The copy paste is a little weird. It'll be reasoning there, but I'll start with this one right here. Scroll all the way down. It looks like this lesson is covering some things that I've already seen here. We've already been doing some parametric equations. We've already been doing some of the syntax I feel pretty comfortable with. So maybe I'll be able to get into some things from yesterday, like this whole zero vector thing and some of the challenge problems that didn't make sense then. We'll see how that goes. So core concepts with visual and examples. So I should be able to identify whether a linear system has no solution, one solution, or infinitely many solutions. I feel like I already understand that. Express general solutions using parametric vector form. Okay. I've done that as well, where I set one of the variables equal to t, and then write the others in terms of t. I think that's what we call free variables, if I remember correctly. Also might be nice today to take some notes, or to go through my notes and get the key terms defined so I can start making a system to review those. Again, my goal is only to spend 1 hour per day for 30 days to master linear algebra, learn at an MIT upper Ivy League level understanding. But at the same time, I don't want to be doing homework. I got a busy life. I got a job. I've got a kid. I got a family. So I'd like to be able to do this in just this hour. But I have some ideas of how I can sort of passively learn stuff in the background as I go. So that'll be for another day though, and I get more into depth with that. And I need to spot when systems are consistent based on some conditions, contradictory rows. So I've done this before, but I could use some extra practice. So when you're solving a system, it's unique if there are pivots in every variable column, that's the x, the y, the z, whatever, and no contradiction. So I need to learn what contradiction means exactly. But that'll be one solution. It's inconsistent if I have a row that's something like 0, 0, 0, and then equals 5 or something. And it's undetermined with at least one free variable, if that means there are infinitely many solutions. Yeah, that's the parametric stuff. So parametric vector form. This actually does look a little bit new. This is a way to describe the entire solution set to a system. And I'm going to write down this key term right here in my notes, get those started. I've got parametric vector form. All right. So let's say that I have the final reduced row echelon form where the first variable is 3 minus 2t and the second variable is t. The way I can write this, it would appear, is I write an x vector and a t vector, where t is all real numbers. That's what this symbol right here means. So I'm describing a line through R2, a line in R2, sorry, through this 3, 0 vector, that's, I guess, 3x, 0y, in the direction of -2, 1. All right, so that's something that already doesn't make sense to me. I'm going to screenshot this. When the system has parameters, like a system that depends on A, you often have to determine what values of A make the system consistent, what values make it inconsistent or undetermined. You'll see this by checking for pivot structure and contradictions after row reducing. So I need to go over pivot structure. And also contradictions. Cool. We got some guided examples now. So we want to solve this system. X plus 2y plus z equals 4. 2x plus 4y plus z equals 7. Sweet. So I can already tell you these look like they're going to have, it's going to be no solutions. What's interesting is that I can see that, well, never mind. Let's go and jump in and do this. So they write the augmented matrix with the coefficients 1, 2, 1, 4, 2, 4, 1, 7. We row reduce. We make R2 become R2 minus 2 times R1. So that makes it 0, 0, negative 1, negative 1. And this new matrix looks like that. This is row echelon form. So I have z equals 1, negative 1z equals negative 1. X plus 2y equals 3. I get that by having z equals 1 here. And then x equals 3 minus 2y. Cool. So once I solve for x equals 3 minus 2y, I can go y equals t. Okay, and then the final parametric form. This is where it's a little confusing still, but the final parametric form, I want to go and take this screenshot and put it up here so I don't lose this. Let the screenshot sit for a second. All right. So then example 2, so this is where it's tricky, this final parametric form. I'm going to have to learn how this format works today. So I have the x vector is 3, 0, 1. Let's see where they're getting that from. 3, 0, 1. Well, I see we have this equation that x equals 3 minus 2y, and the t vector is negative 2, 1, 0. If y equals t, 3 minus 2t is what x is. 3 minus 2t. I see that. I'm just confused where the 0, the 1, and the 0 come in. Are they here too? 0, 1 on the bottom. Maybe the bottom's always 0, 1 like that, or alternating ones and zeros. Not sure yet. So GPT is kind of assuming that I know a lot. They're really rushing through this. I'm going to see what this is in a second. All right, this already looks better from O1 Pro. Look at this whole lesson. But I'll get to that in a second. I found that their hour-long lessons actually can be run through much faster than that. They're not great at the time sequencing yet. Maybe they're learning how fast I move, but the fact that I'm explaining these things, talking out loud while working, means I'm a little slower than I would be. I feel like they just don't have a great sense of that yet, these models. We're going to need to customize some stuff with GPT before it's smart enough to know how long a lesson will take with a specific student. So anyways, solve and determine what values of A the system is consistent. All right. So we need to look at what does it mean if a system is consistent. So I see this augmented matrix 1, 1, 1, 1, 2, 2, AA. I'm going to reduce it by subtracting 2 times R1. So I get 0, 0, A minus 2, A minus 2. And if A does not equal 2, then row 2 has a pivot. It's consistent. It has a unique solution. We like that. If A equals 2, then row 2 becomes all zeros. It's going to be consistent, but undetermined. It's the free variable with infinitely many solutions. When it's 0, 0, 0, 0, that's infinitely many solutions. All right. So was that the whole problem? I guess so. Yeah. So that's not too complicated. I'm going to have to ask for challenge problems later. I found that's a really helpful way to get actual good practice that you'd see in an upper level math class. Maybe, a community college class would be easier and just give me the basics, but I want to really understand linear algebra. I want to make sure that this is challenging me. So let's look at problem 1 here. I'm going to go and solve this. So let's go problem 1. I'm just going to write down, I'm going to solve and express the general solution. So I'll write down these augmented matrices here. I have 1, 2, 1, 5, and I have, I'm highlighting problem 2, but I'm doing problem 1, so I'll highlight that. 2, 5, 1, 11. So I'm going to go that R2 is going to become R2 minus 2R1. So it becomes 0, 1, negative 1. Is that 11? Yeah. So, and then 1. All right. So the new matrix is going to look like this: 1, 2, 1, 5, and 0, 1, negative 1, 1. All right. In order to solve that, I'm going to say this becomes y minus z equals 1. And why don't I have solve for z here? Z equals y. Oh, that's not working great. Y minus 1. Okay, so z equals y minus 1. So I think then I can say that t, whoops. And then if I were to write out this first row now, I have x plus z equals y minus 1. Well, I'll write it with this, so it becomes x plus 2. So getting a little lost here, but I think it's going to become y equals t plus 1. That's another way of looking at this. 2 parentheses t plus 1, that's the 2y, plus z, which is going to be t, which is y minus 1. Oh, I'll just say plus t. Equals 5. So if I write that out, I get x plus 3t plus 2 equals 5. X plus 3t equals 3. So now how do I write this as this vector? I know it's going to be x vector and then something here plus t vector and then something here. So, and I think it's 1 on top and 3 on top. The question is, what do I do with all the other stuff? So I'm going to have to look up an answer to this. Explain this further. Also answer problem 1. A solution written out. All right, waiting for that to load. I'm going to try to wrap up the whole 401 before I jump into 01 Pro. So this is a line in row 2 through 3, 0 in the direction of whatever. Does this mean our row 2? I need to figure out what this symbol means too. So x bar is xy equals 3, 0 plus t negative 2, 1. The point 3, 0 is a particular solution, a point on the line. The direction vector tells you the direction of the line. So a point on this line and the direction. If I have the point and the direction, that's the basics of a vector. So this is a point, this is a vector. As t varies along r, you're moving along the line, tracing out all possible solutions. And I know that's one free variable because we just have t. We don't have multiple things. Okay. So we got the augmented matrix. They simplify it just like I simplified mine here. This looks good so far. We do the back substitution, y equals z plus 1. So they used y instead of z. So it becomes x plus 2y plus z equals 5, x equals 5 minus 2y minus z, x equals 5 minus 2, z plus 1 minus z. So x equals 3 minus 3z. That's basically what I got here. This is the same thing as x. Whoops. I don't want read only. Oh, is that why Notability is not working? It's trying to make me go read only. All right. Well, Notability has been replaced now by Freeform again. That's annoying. They made me subscribe. So, okay. Go back. We're going to go. All right. Day 2 LA, or day 3. All right. So going back to this here, I have back substitution to say that x equals 3 minus 3z, and z equals t. So this is the same thing as x equals 3 minus 3t, which is what I had gotten. The final answer, I have x. Oh, so you solve for x, you solve for y, and you solve for z. So x equals 3 minus 3t, y equals t plus 1, which I got by substituting, and z equals t. So then the way you write this is you draw this x vector, and I write 3, 1, 0, because those are the coefficients aside from the t. And then the t, because it's, okay, I got this now. 3 here, 1 here, and 0 here. It's t plus 0. Then I go plus t, negative 3, 1, 1. And then t is all reals. I don't want to forget that part. Yes, help me visualize this solution. I have no idea how this visual looks, so let's see if it'll help me. I don't think it'll be able to draw a diagram, but maybe it can explain. And also explain what a line in R3. So I need R2 and R3, etc. mean. So that was the first practice problem. I'll see what they say for that. I'm going to go and look at the second practice problem, see how I do with that. Solve and write the parametric vector form. Okay, so this was problem 1. Now we're going to problem 2. Problem 2, I'll write out this augmented matrix. So it's 1, 1, 1, 3, 2, 3, 4, 7, 1, 2, 3, 6. All right, now if I'm trying to solve this, I want to leave the first row. I'll start with the second row, and I'll go R2 is R2 minus 2 R1. Seems like a lot of them have that exact same operation. When I do that, I get that R2 is 0, 3 minus 2 is 1, 4 minus 2 is 2, and then the augmented part, 7 minus 3 times 2 is 1. Now I'm going to do R3. R3 is going to equal, I could just go minus R1, R3 minus R1. Yeah, that seems fine. So that will then equal 0, 1, 2, 3. Huh, that's nice. All right, so I've got a new matrix here. I think I'm going to have to do one more thing, though, to get this in row echelon form. I'm going to need to get rid of this 1 in row 3. I'll write out the new augmented matrix, though. 1, 1, 1, 3, 0, 1, 2, 1. And